Hello and a good day. We are from Group 3. We will be presenting OEL 2 proposal on adsorption rate of methylene blue dye on activated carbon. There are two factors assigned for our group, which are temperature and adsorbate flow rate.
So I will start with the introduction for this experiment. So for problem statement, as we know, controlling pollution in the environment, of which wastewater is one of the main contributors, is a major concern in numerous countries. Before being released into rivers or stream, wastewater must be treated since dyes and other chemicals are dangerous where it can cause severe damage to the human beings. Adsorption by activated carbon is one of the efficient methods for dye removal from wastewater, as it is more practical and technically easier. Therefore, this experiment will study the effect of the temperature and also the flow rate of the adsorbate of methylene blue dye on activated carbon. There are several objectives identified in this experiment, which is to study the temperature effect on the adsorption rate of methylene blue dye to activated carbon, and also to determine the rate of adsorption of methylene blue dye on activated carbon with the effect of adsorbate flow rate. For the variables, the manipulated variables is temperature and also adsorbate flow rate. The dependent variables is the rate of adsorption, and lastly, the control variables is the pH of adsorbate solutions.
Next, I will briefly explain our experimental procedure. It has three methods, which are the first one is functionalization of activated carbon. In this procedure, the distilled water will be added into the flask containing carbon, and the activated carbon will be extracted by filtration. Lastly, the carbon will be dried and stored in a proper place. Functionalization of activated carbon is crucial as a purification and ensuring the removal of organic chemicals. In this slide, two figures of two different factors are depicted. On my left side is effect of temperature and the right side is effect of flow rate. We will use the UV spectrophotometer for both of these experiments. As you can see, the effect of temperature will be using orbital shaker with variety of temperature such as 25, 35, 45, 55 and 65 degrees Celsius. For the flow rate, the adjusted pH of methylene blue by using hydrochloric acid, and the concentration will be analyzed until the equilibrium is reached.
Next, the table shows the parameters that are required for this experiment, which are absorbance, concentrations, and dye removal percentage with respect to time at 5 different temperatures. As for the expected results, when the temperature increases, the dye removal percentage will decrease as the absorbance and the concentration decreases with respect to time. The decrease of adsorption effectiveness due to high temperature indicates the exothermic nature of the adsorption process. In addition, as temperature increases, the energy content will also increase, and thus the adsorbent requires more energy to remain in its state, which then affects the absorption balance. For the next factor, which is adsorbate flow rate, as the figure shows, we can see that when the flow rate of the methylene blue increase, the breakpoint time decreased from 1350 minutes to 840 minutes and to 630 minutes. Increasing the flow rate may be expected to make reduction of the surface field, which will decrease the resistance to mass transfer as well as increase the mass transfer rate.
Next, I will be presenting on the safety precaution of the experiment according to the material safety datasheet. Chemical properties of methylene blue. It is combustible but will not ignite readily. The precautions for self-handling of methylene blue: keep away from naked flames or heat. Carry operations in the open or under local exhaust or ventilation or with respiratory protection. Do not discharge the waste into the drain. Next, chemical properties of activated carbon. It is self-heating substance in accordance with GHS criteria. The precautions for self-handling of activated carbon: avoid it from heated with strong oxidizing agents. as it will react vigorously and violently. Lastly, the personal protective equipment during the experiment is the most important thing. Always wear appropriate eye protection which is safety goggle with sun protection in the laboratory. Wear chemical protection gloves when handling methylene blue, which are tested according to KN3221. Lastly, wash hands and remove any protective equipment before leaving the laboratory. That's all from Group 3.